We're going to be talking about GraphRag today. Jason's from Neo4j.
So the typical pattern for creating a knowledge graph inside a graph database is there are a couple ways you could do this, but kind of one of our recommended paths is to start with the questions you want to have answered. Like, what information are you most interested from your particular data set? Once you know generally what questions you want to ask, that highly informs you in deciding how to construct that data model. So um, what I showed earlier, this is an example of what the data would look like, um, but also kind of. So I'll come back to data models, but data models basically this, but this just to specify the schema of the data, not the actual data entities themselves. So after you've got at least a starting data model, the starting schema, you then can use that to build data import ETL processes to take data from wherever it exists currently and pull it into a graph database. So this is the typical process that has existed at the start of graph databases and prior to large language models becoming a huge thing. Now, this part here, the data model part, this was probably probably one of the more challenging parts to implement because as you saw, there are many different ways you can tie different entities together and many different ways you could represent entities. And that sort of unlimited potential can be difficult unless you're an extremely unless you know that your particular domain space intimately and are able to easily kind of parse that out and put it into this sort of napkin drawing data modeling structure. Ah, so again, this is still a viable sort of development path. Um, but with the introduction of large language models, we're able to kind of accelerate this process. So this is kind of our first part of GraphRag, right? So the two components of GraphRag is using generative AI to help import data into a graph system. And then the second part is, of course, the retrieval part. So Sangil is, I'm trying to understand the advantage of the GraphRag model. My product generates narration scripts for attractions, example, the Eiffel Tower. What are the biggest advantages of using GraphRag over regular RAG for this use case? Okay. So vectors, vector database is great. They're great for pulling like one specific information. So if you have, let's see, so if you've got like a description of a given attraction, right? And it's in some particular document, a PDF doc or a website. Vector database will pull that direct resource very quickly, very easily, and it does that very well. But if you have a multi-hop question, right? So say you're not looking for specifically uh, an attraction by its description, but say you're like, okay, give me a recommendations for attractions for a person who happened to come along with another guest, right? Like, and depending on how much information you have in the graph store, but let's say you've got quite a bit of information on the guests coming in and their guests. So you couldn't ask a vector system like, um, give me like the top three whatever uh, attractions that this person should go check out, um, based on the fact that you only know like tangentially like how this person is interrelated. So the Kevin Bacon, 6 degrees of Kevin Bacon, any sort of like question like that, vectors can't do these multi-hop questions unless you do a lot of work with putting in extra information, metadata, and then starting to have metadata point to other metadata. So there are these strategies that are appearing in vector RAG. But if you take a look at them in detail, they're basically pointing to the direction of eventually ending up at becoming basically a knowledge graph, right? So recommendation systems are a great example of the use of graph-based systems. Also, like kind of tangentially, like say you wanted to do a shortest path plot. So your attractions are in a given space, you have given walkways, you're wanting to know like, okay, when a guest comes in, what is the most optimal route for someone to hit all the attractions that they're interested in, right? So not only can you give them a recommendation of what attractions they should go to, you can also give them a plot of like which attractions they should go to first and then end up at, right? So all like like Google Maps or Apple Maps, the road plotting systems, those are under the hood. They're all graph systems. There is no non-graph shortest path algorithm that I've ever that I've encountered that I've found. So that sort of problem is particularly graphy. Okay.